Right, here we go, we're good. So, welcome back for chapter 4. Smallest chapter of all time. On a very odd screen that you can see over there. Sorry folks, I have uploaded this, haven't I now, into Moodle?
That's 83 slides.
Yeah. No, are you sure? This is 34. You've got the right one, yeah?
34.
Oh, you're on CCNA 4 or something else.
No.
You want chapter,
Not really.
you want CCNA 1, mod 2 it's called, right? Routing and switching essentials.
It's called network.
No, you're wrong one.
Really?
Can't be.
Switch networks.
We time travelled back to last term.
Right.
Got it? Chapter 4, switch networks. Remember it's RSC, not ITN. You got ITN opening there. You want RSC, it's different. Go to Moodle and get it from there. Anyway, when we didn't find the right presentation. Okay, here we go. What we're going to talk about is initially we do switch networks, LAN design, and how switches forward data in these small to medium sized LAN. We'll talk about frame forwarding and collision domain comparisons. Let's swiftly go through the slides then. Here we go. Context is we have a growing complexity of networks. They're already thinking about the word next generation here. So they need to be secure, reliable, and highly available, support a globalized workforce, much more global working is planned for the future, and be able to integrate also legacy. We're not going to be discarding our old equipment. They've got to be able to work backwards with existing kit. A lot of existing kit out there. A couple of you guys work in IT, I'm sure here. Mark, tell me, have you got any legacy devices where you work? Most of the laptops, what are they?
The Windows 7, so that's not too old.
Yeah.
They're about 4 years old. Some of them are out of warranty. We've got a few desktops too.
Windows 7.
Yeah, we've got that's the oldest thing we've got.
What's the hardware? So Windows 7 is an older operating system. What about the hardware?
The Lenovo laptops.
Okay, I'm sure they're not the most recent up to.
No, they're not. They're from about 2000, about 4 years old.
Okay, and then your networking equipment. What do you got there?
I don't get access to that. So
oh, it's a secret, is it?
Yeah, because I'm only on the help desk. I'm not on the third line.
Obviously, can't. So therefore, they can't tell you. Well, fair enough. But you can see some legacy stuff pretty much wherever you go. PCs using in the college are fairly okay. They're i5s, Intel cores, but they're only refreshed recently. Let's move forward. What is in a converged network? So these converged network solutions are a big consideration again for the future. Integrate the voice, IP, voice gateways, video support, and video conferencing. So we got all sorts of traffic. Some traffic with video traffic, if you think about it. Video traffic is a lot coming down the wire on video. You know, in fact, in ways the most because it's visual information, much more so than say a little bit of text in an email. Okay. But given there's all these different types of data, like IP phones are carrying packets of sound. Well, not packets of sound actually. They're just digital packets that have been converted into sound waves. You know, when you're hearing it back, your ears on the phone piece. It's been converted back to sound, having been digitally transferred down an Ethernet cable. So the phones I've got in the college are all internet Ethernet connections, right? Digital. So one of the benefits of having a converged network, rather than having different networks for voice, video, email, and video, as was before, is we've only got one physical network to install and manage. One network. So the concept here of Cisco borderless network, here's an idea, what kind of concept they have. This allows organizations to connect anyone, anywhere, anytime, on any device, securely, reliably, and seamlessly. And because of this, with the CBN, we have the framework to unify both wired and wireless, policy control, policies on access and performance across these different devices can also be managed too. As well as managing both user services, endpoint, and network services. This is what we call an integrated management solution. It's different campuses here, large, medium, and small there. Now there is a hierarchy in the borderless switched network. So these are some of the principles around it. So there's 4 kind of keywords here. One is hierarchical. And this means that at every level, they call it tier, at every level here, there's an understanding of the role of each device. So there's a hierarchy as you go down level, all do different things. Modularity means we can expand and integrate services in, plug them in. Resiliency means that if there's a fault somewhere, you've got a backup line. So the network is always available. And flexibility is the allowing of intelligent load sharing. So there's the fact we can share data down different wires together, and so we're not overloading one line. This 3-tier model is called access, distribution, and core. So the core, you can see here, is the higher layer, then distribution, and then access is the level below it. C, D, A is the order here. And these devices here, what are they called? What's that called there? Yeah, what's that device called though? You've got this device which you recognize here, I'm sure.
Yes.
And what's that then?
Rotor.
Nope.
Oh, it's, what is that? Big gate. Oh, order.
So, a couple of things visually to remember. You see this picture here? This is a multi-layer switch. It's a switch, it's multi-layer. Usually a level series 3 switch. Okay, that's just like a big blob, big box thing. You'll see it more and more.
So it's a switch that one.
It's a switch, it's multi-layer though. Just more advanced, like a Catalyst 3690, something like that. And this above it here, this wall, you see the brick wall?
Yeah.
Suggesting a firewall integrated in some kind of a device which also does routing. Yeah, it's like an integrated thing there. But it's not giving too much clarity about what that actually is. Oh, I'm right. On to the next ones. What do these different layers mean? So we discussed core, distribution, and access. Let's work through them one at a time. Access gives network access to the user. Here it is on the side now. Distribution, this is between the access and the core layer. It aggregates layer 2 broadcast domains and layer 3 routing boundaries. Gives intelligent switching, routing, and network access policy functions to access the rest of the network. Then you've got the core layer, network backbone, full isolation provided, and high-speed backbone connectivity. Now, often, smaller networks that don't need separate distribution and core layer often use a 2-tier campus. We call that a collapsed core network design. What's missing here? What's happening? Can you see this on the picture? What's going on there? Difference between this is that version, and here is a ready. So here's before. Turn it sideways. Collapsed. Yeah. So you see the one in the middle, the access. Sorry, the core and distribution layer. They're both joined together. This is it here. A smaller network doesn't need more than that. We've got a big building here with various levels and floors, all different services. This is enough to do the job. Okay. The role of a switch network. So the hierarchical switched LAN gives flexibility, traffic management, and additional features. It's not.
One previous to that.
Yeah, go back. This one.
Yeah, is that between 2 sites?
Oh, this scenario here.
Yeah.
You know what? If you go to this picture, that one there, you look very carefully at it. That's over 3 sites. Yeah. That one there, with various layers and so on. This has got the full borderless network, you know, hierarchical 3-layer thing going on there. Yeah. This one is just one. It's just shown to be one site on here in terms of the way the access is working. But at any point of this part of it here could be somewhere else. You know, that could easily be this. Chop this in half. That could be elsewhere. Way far away. You know, as long as there's a link between the different devices. Some sort of serial link. This is actually one organization.
Yeah, it's got 2 internet outlets. So
Yeah, you do wonder. Again, it's fault tolerance. That's why.
Right,
It's fault tolerance, yeah.
makes sense.
It's fault. It's just trying to get total resilience. That's why they've got 2 internet connections. They bought 2. They have one which is the main link and one which is a backup link. Same for the router, so the switches and the firewalls, everything has a backup to it. It's totally resilient network design, that one. Okay, so the features of a hierarchical switched LAN, quality of service, we call it QoS. That's for prioritizing different types of traffic, video, voice, over email, etc. Security is additional. Support for wireless networking and connectivity, and support for new technologies. And obviously wireless, much more is appearing in that area. Some form factors, here's some physical hardware. So we've got 3 types of switch configurations. We've got fixed configuration, so this top one here, just literally stuck on top of each other. Yeah. We've got modular, you buy a whole case full of stuff inside it and then modules, you basically stack them together. Look at Google server farm. There's a picture of it online today, actually. You've seen that on BBC News. There's a picture of it on there. It's this huge guy standing there. And it's an article about this new gaming thing they're making. There's usually a whole building full of these massive modular configurations, yeah? End to end, it's like a maze of them. And then you've got stackable configurations already connected because of the daisy chaining of the cabling. See how it's going over itself, yeah? They're all connected to each other physically. So what we've got to think about when we're selecting, buying a switch or looking to do procurement is we have to think about a few factors. One is obviously the budget. Then something called port density. What does that mean? Haida, what's port density mean? Tough question for you.
Sorry?
Port density, what does it mean, that word?
See how many addresses can be configured?
Kind of getting there, but remember, this is about, I'm talking about hardware. Nothing clever.
Oh, how many physical outlets?
Got it. Yeah. Port density. How many?
Yeah, it's 24.
Yeah, got it. So look at the screen. Yeah, so you got 20, this one here, yeah?
Yeah.
That's density, that's got like a 6, 12, 24 ports.
24, yeah.
So this one here has got 48.
48, yeah.
Yeah, so that's got more density, that's more ports.
Yeah.
That's it. So how many ports do you need? Then you've got power. So how much power supply is an issue. Or power of this, maybe it means by speed also. We've got reliability. We've got port speed. So do you want gigabit Ethernet or fast Ethernet? Frame buffering. How much storage is on board that can hold stuff before switching? And scalability. Is this business growing or shrinking or whatever it is? And are we designing based upon that? So now we're into the switch environment. So switching is a general concept in networking and telecommunications. We have a LAN switch here. If you remember back into CCNA 1, there's a little thing about the MAC address table and also the ports and switches. You can recall back. This is a very similar thing here they're going to show. This packet here is arriving, yeah, on port 1, looking to go to EA. Okay, so it's just what it does, it looks up on its table. Where is EA? EA is on port 4. So the message enters port 1 with the destination address of EA. The switch will forward the traffic out of port 4. EA is any address, right? Imagine it's like going to a PC somewhere. So it comes in on 1, it goes out on 4. That's how it gets there. And the layer 2 Ethernet switch forwards frames based on, and with switches, it's always about the hardware, right? The destination MAC address. The 2 criteria that it makes a decision based on is where does it come from, the ingress. The ingress layer was 1, and obviously then destination address. Ingress port 1, going to destination. Little video there about how that works. This should be fairly straightforward. There are different types now of switch forwarding mechanisms I'm now going to refer to. So let's go over here. You just talk about this diagram, you can see. So a store and forward switch receives the entire frame. So what's happening here is with the switch, the whole frame is coming in and it computes something called the CRC. Have you heard of the phrase CRC before? CRC, does that mean anything to you, any of you?
Final check. Over there.
Check is the good is definitely a part of that word. It's like a checksum. In a way, it's like a calculation based on the amount of, maybe it's like looking at the data and it makes a number based on it, which shows me I've got everything. Yeah. So if the CRC is valid, checksum is valid, the switch looks up the destination address, where are you going, and then determines which interface to go out from. Then the frame is forwarded out the correct port. Switch forwarding. So it's receiving the entire frame inside, computing, then doing the forward lookup. Okay, that's one style. Store and forward. We call this store and forward. Make sense? Storing, then forwarding. Then we've got something called cut through. So a cut through will take not all of the frame, but some of it. It will cut a bit of it. Yeah, we'll cut a part of the frame, and then before it's entirely received in, it takes a part of it out. And it says, at a minimum, the destination address of the frame must be read before the frame can be forwarded. And it can be defined as to how much you can receive, how much of that frame you can take. But at the least minimum, you must know where it's going to at least, yeah, before you forward it on. You can imagine which one's going to be faster, A or B, this or this. Yeah, you got it. This one's going to be quicker, right? So store and forward now in more detail. It just talks about what goes in. This is the frame size and what goes in it. You've got a header, network header, transport header, and data. There's this checksum at the end called the FCS checksum. CRC goes here. This frame header, if I open and expand it, has got a preamble, destination address, source address, and a type. Store and forward tells receipt of the entire frame. It's up to about 9.2 kilobytes. We call that those jumbo frames, yeah? Before a forwarding decision can be made. So some features, error checking. We always check the frame check sequence, FCS value, in the last field against its own FCS calculation. So it just checks this is all complete before forwarding it. It does require that for store and forward. And automatic buffering. The ingress, the incoming port, has some buffering, which means that it has some storage space that allows stuff in for a while. And it provides the flexibility to support any mix of Ethernet speeds. Sometimes you've got like a very fast, incoming frame, and you've got to hold on to it before you can handle it and do something with it. So the idea is that it just gives some buffering to enable that. This is the primary LAN switching method, store and forward. That's the default. Cut through. So as I mentioned before, we can cut a part of it out and only forward that part on. So it just says here, frames can begin to be forwarded as soon as destination map is received. So when we've got that in, we can start forwarding straight away. You know where it's going, right? Rapid frame forwarding. But problem is it also forwards frames with errors. Hasn't got any checksum. This is not even used, okay? No FCS used. So therefore, you'd have a problem with errors coming through it. It's a modified, there's also a version called fragment free. This is a modified form of this. This switch waits at least for 64 bytes to pass. They call that the collision window, yeah? So 64 bytes of stuff can go through at least. It's called fragment free before forwarding it. This gives better error checking than cut through with no increase in latency, which is like a delay. So really this is a much better version of cut through, yeah? All right, now, collision. So, it says here, in a hub-based segment, these devices or networks compete. Yeah, therefore collisions take place. Ethernet switch ports operating in full duplex eliminate collisions. Why is that? Hard question to think about. Let's ask one of you, ask for it. My question is, why do Ethernet switch ports in full duplex eliminate collisions? Say again? I think we're going to be saying probably the same thing. Normally, there's competition to send stuff through. When you got full duplex on all ports, you can have parallel. Yeah, you've got a parallel transfer. It goes both ways, right? Which means that there's no issue of waiting. In half duplex, you have to wait Yeah, like I can't send now because I'm receiving, you know, and when I'm sending, then I'm not receiving. It's that kind of thing. Whereas a full duplex, you can go both ways. No need to hang around. All right. If you Ethernet switch ports will auto negotiate full duplex if connected to full duplex devices. That's the default setting, auto negotiation. However, if connected to a half duplex device, the switch port will operate in half duplex and it will become part of a collision domain. Something to consider. We've got broadcast domains. So one switch or multiple interconnected switches form a single broadcast domain. So whenever you've got switches that are on their own or together, like this example here, we have got a broadcast domain. That's one there. There's one whole area there. When a switch receives a broadcast frame, it forwards the frame out of each of its ports except the ingress port. Remember this idea? Like you have one input coming in, and when it pushes out of all ports. When it's a broadcast frame, yeah? That's what broadcast essentially means. It never broadcasts, by the way, back from where it came from. It doesn't do the ingress port. When you've got two switches together, the broadcast domain is bigger, okay? Because the broadcasts are propagated from here, all around here, but yeah, that's what it's saying. You're right, I think. Indeed, it also goes to broadcast there, but you also broadcast here, which means you also broadcast there. Broadcast goes everywhere, right? So if you've got tons of switches broadcasting, we get a problem. Yeah, we've got broadcast going on constantly and we get this problem of congestion. Yeah, it's inefficient to have broadcasting going on every single domain. You don't need to. Sometimes you want to just limit and say, you know what, broadcasts are limited to here or just this border here, no further, etc. Okay, so congestion can be a problem within broadcast domains. Now, how can we alleviate this? So the switches have some abilities to alleviate congestion. And firstly, establishing the full duplex links, therefore collisions go completely. High port density, so having more ports means less sharing, or there's more opportunities to send things down. Large frame buffers, port speed, fast internal switching. I think the cost per port is something to consider. Now, it's cheaper to have higher port density than have many of these. These half switches. If you've got one of these is two of those, right? So the pricing works out cheaper. Okay, it's all about how many devices you're connecting up to and how big the business is. Sometimes one switch is enough, or sorry, two, one as a backup. So that's the chapter done. Part one. Okay, I'm gonna give a few minutes, just 5 minutes, just chill time. Okay, and then I want to start the next block, which is going to be the switched configurations. So you want to just have a look through the slides of chapter 4, flick through the activities. There's no packet tracers. I'm sure you're happy about that. There's a syntax checker, which is quite a useful thing to do, just to refresh yourself. 4, 3, 1, 2, and some activities. Just going to let you have some time now, just looking around the resources on that, so you can get your head around it. So 4, 3, 1, 2, okay. That is the syntax checker activity, but there's also little activities in there. Do videos, just spend some time wandering around that stuff. Catalyst 2960. I've got one in there now. Go to the loop for a moment. All right. Okay, right. Hopefully you've now absorbed chapter 4. Looked around it a little bit. This has been left on recording all the time. Okay, hope you're saying nice things. the other day, I didn't do my other class. I had 2 classes. Front room, 2 rooms over there. I had one teacher who was doing a lecture for both classes. So he was streaming in one room and then playing in the other one. What I didn't realise was that when he was in one room, the other students, I was recording their voice like they were talking in the class. They captured everything that they talk about when the teacher's on there. I was thinking, oh my God. These are youngsters, right? Shocking stuff. Well, you don't really want to hear what they were saying. But anyway, let's move on. Okay, folks. So chapter 4, be happy with that. It's quite easy, isn't it? Would you agree, I hope? Are you all right with the concepts? Crystal clear, understanding? Yes? No? Any questions? I'm going to ask all of you individually. Hi, Dad. Questions? You clear? Vadim?
You can ask me questions. I'll get some wrong, but I'll get some right.
You ask a random question. Wait, a trivia quiz question. Okay, what does a cut through switch do? How does it work?
Cut through switch reads the address, the address where it's going from before the whole packet and starts sending it through.
Yeah. Good.
In a roundabout way.
Tough question. The answer Attila actually is tough. Attila, fragment-free switching, how many bytes does it read of the packet from the frame before it can forward on? Fragment-free. It's a tough question. This is a tiny part of detail of the slide. Okay, I'm going to let you look at your resources, chapter 4, and find out for me. Fragment-free. It's good. Tough question, actually. So catch me out a little bit, I'm afraid, there. Sort of very small detail on one slide. Let me show it to you. Ready? That's cruel, actually, in a way. C4. Oh, where's it gone? I can't open that for some reason. Already closed it. You'll find it in your details. Fragment-free switching is 64 bytes. Okay. Tahir, what does port density mean?
The number of ports, the more you've got, obviously, more economical, and you've got throughput.
You're good. That's right.
Mm.
What's a stackable switch configuration?
When they are like connected to each other.
Good. Excellent. All good. One more thing to think about. So, we're now going to look at the next stage. There's a few kind of things in the best practice that are quite useful actually here. Let's mention a few things actually on the best practice stuff. So, can you imagine like a packet tracer topology, 3 PCs connected? The demonstration will be useful, but we go through this. Just says a few hints here, okay? Question mark is a key to iOS survival. It's reminding you a question mark is your friend in any Cisco device. And you constantly practice and use that question mark. Attila, your second question. What does question mark do on Cisco iOS? What does that command question mark do? If you're typing a statement and you do space question mark, what happens? Cisco iOS.
Question mark only, right?
Yeah.
It's the option. Trying to go to command.
I'll go back to rule.
Shows the commands actually, but
Yeah, it
all
shows,
the available commands what we can have with the
great. It shows you all available commands. So if you use it by itself, but if you use it with,
then it completes the commands.
great. So it's like a tree, yeah?
Yeah.
If I was doing, say, configure space question mark, I'll get all the configure options. Okay, so that's just question mark is your friend. To remind you, how important switches are to any company. So even if you're an entry-level technician, highly likely you'd be asked to cable and configure a switch. And then some following terminologies: ROM, flash, RAM, and NVRAM. I'm going to read these a couple of times just on what they mean. Little summary of it there. Let's just go into now the main stuff in this chapter. Basic switch configuration. Here you're going to configure basic switch settings to meet requirements of a network, configure Cisco switch settings, configure ports to meet network requirements. Bit of recap on previous chapter on switches, CCNA 1, and then we go a bit more deeper into it. Then basic device configuration, configure a switch using security best practices in a small to medium-sized business network, configure the management VI on a switch, configure port security to restrict network access. Big hint for you, this sort of stuff is going to likely to appear in your skills test. Switch configuration you need to know. Start with configuration of a switch from boot sequence. So when we power on a switch, there's a boot sequence that takes place. Stage 1, post takes place, power on self-test. I'm on slide 19, by the way. Want to find it, yeah? So you do, got it? Power on self-test. A program stored in ROM executes and checks hardware like CPU and RAM. Okay, it's like that BIOS. When the PC gets turned on for the first time, there's like a post happens. There's a self-test first. Then the bootloader, which is also in the ROM, runs and initializes parts within the CPU, initializes the flash file system, and locates the iOS image. It's like locating the operating system image here. Okay? If it can't find the right image, which should be set within an environment variable, it will look through the flash file system, searching for an image file, loading it, and launching it found. If it doesn't find it at all, the switch shows a prompt, switch : where you can use some very basic commands to provide access to the OS in the flash memory and files to load or reload an operating system. Okay, that can happen. If an OS system loads, the switch interfaces are initialized, and any command stored in the startup config file also load. Okay. The startup config file is stored as NVRAM. So continuing the boot sequence. This boot system command, how you set the location of the file is you write this command here, slide 20. Boot system flash, click on your own screens there. 26, and it's got a path to where the image file is, and there it is there. Command, storage device, path to system, and file name is there. That's how it sets where the iOS is actually stored. Now, if it's a system crash, how do you recover? The bootloader prompt can be accessed through a console connection to the switch. So you cable the PC to the switch console port, like you know the blue ones on the back of the PCs here. There's your kind of console line. Configure terminal emulation software on the PC, PuTTY or what's it called? Term. I've not used it for ages. Unplug the switch power cord. Reconnect the power cord. And at the same time, or within 15 seconds, press and hold the mode button on the front of the switch until the LED turns amber briefly and then turns green. It's something you have to reboot. Hard reset on this switch there. Okay. The bootloader command prompt is switch : instead of switch bracket. And there's some limited things that are available at that stage, switch : and you can use the word help to get what the available commands are if you're not sure. There's some of the LED indicators on a switch 2690, which looks like to me, yeah. So Catalyst 260 switch here. This shows you the kind of stuff that's going on. Systems LED is number 1, right at the very top there. Shows if the power has been applied. Port LED states, next one down. Number 2 is the off. It just basically says about the color really, the port LED. Number 8, okay, is a port LED, which is across the top here. So each port has its own flashing light on it. So wherever that light's doing, you can imagine like this one, say I had a plug into it. Remember when we were doing in there, cabinet. some of the basic switch configurations we're doing now, you could see when you connected it, the cables were flashing. So if it's off, no link will shut down. Green, which means it's good, link is present, so green is fine, and flashing green is also fine. That is a data activity. Yeah, there's actually something going on there. Green and amber alternation is a fault in the link. Amber, port is not sending data, but this will happen when you start the machines up. The first 30 seconds anyway, you'll get amber, yeah? And then it will go off that turn green or flashing green. Blinking amber, port is blocking to prevent a switch loop. There's a blocked port if you've got amber blinking there. Okay. And there are various things down here, like you look at SIST, RPS, STAT, duplex, speed, PoE, are various things there. Also that are set up. What does PoE stand for? Who said that? The Deans or Mark? Ah, Mark. It's like a ventriloquist over there. He's moving his mouth, but actually he's coming out of someone else. Yeah, that's what's going on. So yeah, you're right, power over Ethernet, well done. And that's something, you know, if you've got power over Ethernet, you can power supply things off an Ethernet cable alone. So preparing for basic switch management. So to configure a switch, you obviously need to have, you know, ideally remote access. You don't always want to be running up to the switch physically and having to console cable it. So you want to have some kind of a remote access to the switch so you can configure it. So what we've got to do is give the switch an IP address, subnet mask, but also a default gateway. One particular SVI is used to manage the switch. So a switch IP address is assigned to an SVI. By default, the management SVI is controlled and configured through VLAN 1. So just remember, VLAN 1 is your default address for managing a switch. We often call VLAN 1 management VLAN. Okay. Now, generally speaking, because it's a default, you know, and everyone's going to use VLAN 1, it is better practice to use a VLAN other than VLAN 1 for the management VLAN. Sometimes people might use 99. Okay. Little hint here. Remember, the switch console port is on the back of the switch, not the front. Yeah. A reminder there. Now, configuring a basic switch management access with IP version 4. Here's the different commands to note down, put in your engineering journal and so on. Enter global config, conf T. Now we're going to enter the interface configuration for the SVI first. Okay, we're doing an SVI configuration. Interface VLAN, I've chosen 99 as a management. Okay, IP area. So configuring the management interface IP address now, once we've got into the interface, we're now going to set an IP address for it. This is so we can remote access the switch. Otherwise, we can't. IP address provided there, and subnet mask, followed by no shutdown. Then we exit. Now, after that, after we've exited, we go back to the config level. We must also configure a default gateway for the switch. Let's say, why is that important? Notice the address 172.171.991 is the address for the router interface. You see here? Right there. Okay, default gateway. Default gateway is a router address and is used by the switch to communicate with other networks. So there's no other way beyond this switch unless you've got this router on a default gateway to catch all addresses beyond our own network. We then do an end command and we copy the running configuration to start up configuration there. You will have a packet tracer to practice this with. Here you go, basic switch configuration. So someone remember, can someone please keep track of this as I go through it? Yeah, hi Dad, you're the one who always, the manual does this for me. 5116, remember that. You're gonna memorize it. Yeah, that's really cool, man. How about you see how many you can memorize in your mind, yeah? I'll read them out to you, and then at the end you tell me how many they all are. Okay, got 5116, first one. You can't write this down, yeah?
I'll do it.
It's a memory challenge. He's writing it down now. I know. We're already forgetting it. What happened to the human memory and this amazing powers, eh? So after lab, we are going to do labs after break. Duplex communication. We've got here gigabit Ethernet and 10 gigabit Ethernet NICs. See here, guys. Hello, everyone. Boys. Back to screen, please. Right, gigabit Ethernet and 10 gigabit Ethernet NICs require full duplex operations to operate. Why? Why do those type of NIC cards require it? Big hint here. Gigabit. We are coping with a lot of speed here, yeah? And with a gigabit connection, because of the volume of stuff going through, imagine like if you've got half duplex and you're having this thing where you're waiting for the line to clear before you can send stuff, and this is gigabits of stuff, you could be waiting a long time, yeah? So given the bandwidth is bigger, the gigabit Ethernet and 10 gigabits require full duplex, so they can send and receive simultaneously. Bidirectional communication, and you've got unidirectional, half duplex, send or receive, one or the other. Now, with switches, you can configure duplex settings. So configuring switch ports at the physical layer, some switches have a default setting of auto for both duplex and speed. If they're mismatched, you'll get problems, connectivity issues. Always check duplex and speed setting using the show interface ID command. Yeah. All fiber ports operate at one speed and are always full duplex. And here we go, you can see here. Full duplex mode. Here's some commands now. So here, what we're doing is we're doing configure terminal, interface fast Ethernet 01, duplex full, speed 100, end, copy run start. Okay, we're doing a full configuration, duplex and speed settings there. There's a thing called auto MDIX. So some switches have the automatic, this is a bit of an odd word, but automatic medium dependent interface crossover, MDIX. And this MDIX feature, the interface can detect the required cable connection type, straight through or crossover. And they can configure the connection appropriately. So it's like a detector, yeah, on what cable's been plugged in, and it also works with that cable connection and knows what it is. So if you're configuring auto MDIX to be enabled, you enter global config again, interface fast Ethernet 01, this is on S1 I'm working, duplex auto, speed auto, MDIX auto, and then end. Copy run start, and there you go, you configured that switch with auto MDIX to detect required cable types. Now if you want to verify this, you've got a command, show controllers Ethernet -controller will show you if auto MDIX is on or off. Straightforward command there. That's on 29, 30. And also you can verify your switch port configuration by some of these commands here. These are some common commands for switch iOS. So you can do stuff like interface, you know all these. Running configuration, you know that one too. Show running configuration also shows you some of the stuff inside the switch configurations there. Verifying switch port configuration, you see those interfaces are up and which ports are up to. We'll show you there, layer 1, layer 2. Looking for issues, use show interfaces. That will show you any common media issues. So if it says up and if it says interface is up and line is up, you've always been wondering because you might come across this error before, then it's an operational link. But if it says down and down, we've got an interface problem. And this is a breakdown now of how this particular output of show interfaces, all this information, what does it mean? We have 8 output errors, a lot of collisions, and 10 interface resets here on this particular problem. So it's just explaining here what these things mean. What is a runt? What is a giant? And runts and giants are these different sized frames, 64 for a runt and 1,01518 is a giant or a jumbo. It's just showing you, well, if there's an error on that particular interface, it shows you more information about it. So if you ever come across a problem on a switch, here's a troubleshooting diagram. Form show interfaces. Is the interface up, yes or no? If it is up, check indications of noise and interference. Yeah, remove sources. Verify duplex is properly set on both ends. No, verify proper cables. Check cables for damage. And verify speed is properly set on both ends. And you've got yes and no. So if the problem solved, if it's not still solved, it says document and escalate. You can't fix it based on these two options there. Very simple troubleshooter there. That's something I suggest you might want to have, in your skills test, or bring it with your skills test so if you get stuck, a way of troubleshooting. Okay, on to switch security now. Last section, yes it is. Okay, last block to do now. Okay, right, security. Get back on SSH. Remember Telnet? Who's used Telnet before? Remember Telnet?
Yeah.
If you have Wireshark, and you've got someone, let's just say, right, here's a little sneaky scenario, right? Someone can play the role in the class of cyber hacker. Who wants to be a hacker? Put your hand up, Ida. That's brave, isn't it? Ida, you're the hacker, yeah? Okay, you're a hacker. No, you're a hacker. Now, what is it? I'm doing a Telnet. Like, Ida would love to be a hacker, but paid hacker, paid.
Yeah, exactly.
Which country are you from? Make it more interesting. We'll get culture to it.
Let's say Iraq.
Russia.
Okay. They always say Russia are the best hackers in Russia. Someone might say that. Obviously, Russians are very good at hacking. China have got the best, one of the best IT skills for hacking, right? Yeah, yeah. What's that?
Should I go there?
No, just makes it interesting, doesn't it? So let's say, right, okay, you'll say you've chosen wherever you are. I am, okay, somehow, right, you've got Wireshark set up within, yeah? You've got into our network with Wireshark, and I'm doing a connection to, Telnet connection to my internal server. I'm transferring credit card details via Telnet. I mean, this is such a bad thing to do, man. Would I ever do Telnet transfer? Worst thing you do. I'm transferring credit card details or some information via there, yeah? Now, because Telnet does not scramble anything, it's like encryption, right? So if I'm typing the command and you Wireshark can you tap it, you're going to see exactly what's going on.
Really?
Yeah, literally, you'll see it. Wow. You'll start seeing the details of stuff, like real kind of information. You'll see text. Whatever I'm typing, like I'm typing in the commands, yeah. You'll start seeing
I can see it.
You'll start seeing Wireshark can tap it, yeah? So Wireshark can do that. Yeah, you'll see all that stuff. So this thing with Telnet, it's just bad software. Now SSH, at least, if I used PuTTY instead to do this, and you try Wiresharking into that, you're going to get total junk. You won't see anything of any meaning. It'll just be scrambled stuff. It's just all encrypted on quite a complex key as well. It's a long encryption key on this, yeah. So that's the thing about security. Why we always recommend to configure something called SSH to connect to a switch or any device. Use SSH, okay? Otherwise, Telnet becomes like a problem. Here's a Wireshark capture of SSH. You just see it's like looks like this. Yeah, that's Wireshark SSH. Scramble junk. Here's Wireshark capture of Telnet. A bit more information than you might want to say. But you start seeing a lot of stuff actually. You start seeing all the details of what's going on, where is it going, what addresses, it all comes up, and even more can be seen with it. So SSH needs to be set up. Now, some of the things about SSH is, because SSH is cryptography and security, a switch must have an iOS version, K9, at the end of the iOS file name. So the K9 in that file name there suggests we have got cryptographic capabilities. so we can configure and use SSH. If you're not sure, use the show version command, and you can see here K9 is there, yeah? Now to configure SSH, some steps we've got to follow, yeah? So to make it a secure setup. Your skills test may have, very well have, int SSH configuration in it. So remember these steps. Verify SSH support, part 1. Do we have it? 2, configure the IP domain name. You must have a domain name with, yeah, when doing this encryption.
Let me ask you.
Yeah.
So this K9,
Mm.
then the suite must have this thing.
Yes, if you run show version and you see K9 come up, then you have got cryptographic capability. You can have encryption and you can have SSH.
My old switch doesn't really have it. I needed to install it.
So you can't
I
configure
couldn't
the
really.
SSH.
You cannot
Yeah.
actually make a description key. It doesn't recognize the command at all.
Oh,
So it was like and after I found out that we need to update it really. And after updation,
But
it's
that,
actually start to give it like description key.
cool.
Otherwise, you don't understand the command.
Which switch did you have? An old one.
Yeah, but it was 3550 from 2011, so I needed to update it.
iOS was old.
Oh, really old.
iOS was old. Okay. Okay. So we configure a domain name. We need to get a domain name, and this often is forgotten, commonly forgotten command. To create keys, we have to have a domain name. It's a part of it. Then we generate what we call key pairs. Now, an RSA key pair, the way it works is like say, I have a key, and Fabrizio has a key. We both have a key, yeah? It's a pair. I have one half of the key pair, you have another half of the key pair. We both have the secret code to crack whatever we're sending to each other. I can encrypt with my key, you can decrypt with your key. You got that?
Okay.
So what we're doing is with cryptography is we are generating a key pair, both sides, yeah? Receiver, sender. And it's called, it says RSA. It's a type of encryption method. So we do crypto key generate RSA. And because our domain name was cisco.com, it says the name for the keys will be, then it asks the question, how many bits in the modulus? Now the modulus, okay, it says 512 default there and 1024. That's how many, it's almost a bit like this, how many bits? Think about bits as like a storage thing, box, yeah? Remember you've got 8 bits in a byte, it can be 0 or 1, right? If you think about 1024, if there's 1024 bits and there can be 0 or 1, we've got a lot of possibilities for numbers, you know? 1024 bits, imagine in binary, 0, 0, 0, 0, 0, all the way to 1, yeah? 1000 lines, and then 1 at the end. Then you have like 1, 0, and you have 1, 1, and you go all the way up to 1, 1, 1, 1, 1. That's tons of bits, right? And the opportunity to store stuff is big. It's like 2 to the power 1024 is how many types of, you know, how much storage I've got potentially in that. And then I use that information combined to do this thing we call hashing. Yeah, it takes some text and it transforms it into something junk. Yeah, and then only the other key can unscramble it. But I'm using 1024 as a power to multiply. 512 is obviously less. It's less powerful. It's still very strong though. And this is like 256. You can go at different levels, yeah? 512 default, 1024 is powerful. So once I've done that, I've set my keys up. I've made my modulus. I then will do a username. I'll say my username says admin secret CCNA. Okay, I'm making, these are user authentication lines, okay, which I then can use to log in. So you've got a username and I've got a password. The user is admin and the password is seriously secure CCNA. And then you do line VTY, which is the same as before, 015. I'm making 15 lines. Then the key thing here is now I'm saying transport input SSH. If I do transport input all, I enable telnet and SSH. But if I do SSH, it is only that. I then do login local. I then do exit. I then say IP SSH version 2, which is actually configuring the SSH type, and exit again. Okay. This login local command, by the way, forces that use of a local database for username and password. Okay, it makes it look up only locally. All right. Now to verify SSH, you can connect to the switch using SSH with something called PuTTY, which is software. And when you log in with PuTTY, can you see on your slide 40, please? There's the IP address there. So you put your IP address in, and you must tick this box SSH. You guys will all see that, please? Little SSH thing there. You tick that SSH thing. Because in the past, we used Telnet.
Yeah.
Use SSH, you go here, and you type that address in, and you go in. All right? Login as admin, using keyboard interactive authentication. Password goes in. You're connected via SSH there. Good stuff. And to verify, status and settings, show IP SSH on the switch will give you your, look at the key. That's the key, yeah? It's very sophisticated, long bit of, like a password. Look at that. That is pretty hard to decrypt, you know?
Really big.
It's long, isn't it?
Yeah.
That's the RSA key. And then you've got this encoding going on here. And there you go, SSH is running. And you've got the type of encryption, it's called AES-256. There's various types of encryption styles. That's what's being used there. All right, there's a packet tracer to do configuring of SSH, something you'll be doing. Next, secure unused ports. Now, another thing is port density. If we've got ports and they're not being used, we should disable them. So we can shut down ports one at a time. Yeah. If you do a show run, you'll see the state of all interfaces. You can disable an individual port by simply having a shutdown command. Shut down. That's it. You can just say interface fast Ethernet 04, shut down, and that will shut down that particular port. Now, more about port security. Port security limits the number of valid MAC addresses allowed to transmit data through a switch port. So what you're saying is, if I restrict ports from operating at all, then there are limited numbers of ports I can accept the ones from. I mean, okay ones from. Yeah, so you might have 24 ports. You might only say, I only want to work with 3 for incoming data. So if a port has port security enabled and an unknown MAC address sends data, the switch gives a violation saying you can't do this. Yeah, so if it's an unknown MAC address sending something across and the security is on, it won't let it through. And the default number of secure MAC addresses allowed is 1. You must have at least 1 that you do allow stuff from. You can't say 0. Yeah. Methods used to configure MAC address within port security are commands. Switch port security, MAC address is how you do static secure MAC addressing. Okay, that's how you configure security on ports there statically. Dynamically, this is learn and remove switch restarts. There's that version also. And the way this is done is we call it sticky secure MAC addresses. Dynamically learned and added to the running configuration. Switch port security MAC address, sticky MAC address. Disabling sticky learning, convert sticky MAC address. Oh, this is really weird language actually. Let me just translate this for you. I'll work out myself. Okay, what's happening is simply, if you've got a running configuration, those MAC addresses that are coming up, sending things through, are dynamically being learned and added to the running config. If you turn this off, they don't get added to a running config. So they're made to being like, dynamic secure addresses that suddenly appear. You're going to use them for a while, yeah, but they're actually then removed from the running configuration. It seems like a dynamic on and off thing. It just comes up, it can be used, and it's taken off. That's the idea behind this sticky option. Violation mode. So we've got 3 violations on port security. Protect. Here, data from a unknown source is dropped, but there's no notification. So protect is like silent. Doesn't say anything, yeah? Something comes from an unknown source, no comment, it just doesn't make a comment. Right, drops those data sources. Restrict, same thing, it drops it, but it gives a notification. It says like there's a violation. And there's a certain counter called the violation counter, which gets incremented. And it counts how many times there's a violation. Then there's a shutdown state, which is the default mode. Error disabled, and the port LED turns off. The violation counter increments. So if there's like an unknown MAC address pinging or doing something with this particular interface, if it's in shutdown state, it will become error. It will immediately turn itself off. Yeah, it just shuts itself down. It issues the shutdown, then the no shut command to bring it out of the error disabled state. That's what you're going to do to get out of it. So here's the various things. Look at the types of options we have. Shutdown shuts down the port. It's the only one that shuts it down, actually. Yeah. The other ones have an increase in the violation counter. The only message is coming out with syslog. It's restrict. That's like a messaging thing. Here's an example of how this can occur. A station with a MAC address not in the address table attempts to access the interface when the table is full. An address is being used on 2 secure interfaces in the same VLAN. Configuring. So just some settings. Port security is disabled. The maximum number of secure addresses is 1. Violation mode is shut down. Sticky address learning is disabled. This is the current situation set up here. So those things can be reviewed and adjusted with Cisco iOS commands, as shown previously. So before we configure the port security features, we place the port in access mode and use the switch port security config command to enable port security on an interface. Just observe. Specify the interface to be configured for port security. Interface fast Ethernet 018. Here we go. Switch port mode access. Don't forget that. You must put it in access mode. Switch port security. This now enables port security on 18. How do we then configure sticky port security? So we specify the interface to be configured. Fast Ethernet 19 this time. Switch port mode access. Switch port mode port security again, same as last time. And what we're going to change is the maximum number of addresses allowed on the port is going to be 10. We're going to say we can't any more than 10 ports connected. So we say switch port security maximum 10. And we're going to enable sticky learning. So devices coming on and off, those 10 devices will be kept, yeah, and removed from the running configuration. Switch port security MAC address sticky does that. Now to verify this, use the show port security interface command to verify the maximum number of MAC addresses and how many are learned dynamically using sticky. Use a show running config command to see learned MAC addresses adding to the configurations, all very useful things. Show running config, show port security address, shows how MAC addresses were learnt. It says there's secure dynamic and secure sticky down here. So you can see the kind of type of where we're learning to. Ports in error disabled state. If there's an error message, you get a violation. And there's a comment, you get a switch console message. Interface, change state to down. It says up here, security violation occurred caused by a MAC address on this port. You can be very specific. That means you can work out exactly which machine it was, yeah, that caused that violation. Because you know the MAC address. Nearly there, guys, sorry. 51, ports in the error disabled state. Check the port status and port security settings. So you got the status there. And the port security fast Ethernet. It says, do not re-enable a port until the security threat is investigated and eliminated. You must first shut the port down and issue no shutdown to use the particular port again after a security violation has occurred. There's some packet traces there. Memorize, Ida, 5227. Another packet tracer, troubleshooting, 5228. And a lab here, 5229. Yeah? Right, folks, that's going to be the practical work now. Ida, read out to me the full labs, please, with your great memory.
Yeah. It's 5416.
Yeah.
5227.
Brilliant.
5228.
Very good.
And 5229.
Yeah, it's everyone. Good one, my friend. That labs and packet tracers, yeah? Cool, right, let me get this up and running for you. You guys look through the resources now, have a little flick through stuff. I'm gonna get this stuff printed for you, for ready, after your break. And you can get stuck in then.